But then people have started to use, for example, Arduino to create things that are useful in a way that solve certain kind of problems that further explore new directions. So for example, this is a sign language glove. It's a prototype of a glove that interprets sign language. So if somebody is not able to speak, they can sign, and this tries to understand what kind of gesture you're making and displays on the display the word. So the world of assistive devices, it's an interesting, I mean, there are also some startups here that are working in that area, but sometimes, you know, the needs of the user are very specific. So the ability to have a platform that you can quickly use to build something very specific has been very, very, very successful. This is, for example, it's another device made by an Indian inventor, which is, this is some kind of it's a small ultrasound-based radar that can be worn by somebody who either is blind or has very little eyesight to detect obstacles in the vicinity. But this is interesting because it was created by a very young kid from India who created a product that has an application in a lot of cases. Also, there are other cases that are a little bit particular. This one, for example, it's a wearable pet that can be used by people who are that have certain sort of mental, say, conditions. So in a way, when they get anxious and nervous, they can the pet detects it and starts to move and become anxious. So in a way, the person trying to calm down the pet, in a way, they have tested that actually provides some calming and relaxing effect to whoever wears it. So this is a prototype from the university, but it's very close to an almost finished product. So this is another project which is interesting. What's happening now is that people are starting to approach machines that nobody thought you could build yourself. So, for example, this is a CAT scanner. And the CAT scanner is, 3D radio, 3D X-ray, so that it used to completely visualize the inside of, for example, the brain when somebody has a condition in the brain. And in this case, somebody designed this machine. The whole machine is laser cut. So it's built from laser cut parts, so it's something that is easy to share online, easy to build. And then it contains an Arduino. At the moment, the images that it produces are quite low resolution, but they're very promising. There are some CAT scans of avocados and peppers on the website, but clearly you don't want to put a real human being in here for now. But in a way, I think the tool is very interesting because in a way it can teach, for example, to students how a CAT scan machine works, so you can understand how it operates. And from another point of view, it could be used at some point to develop a low-cost machine that could be shared freely online, so people could build a machine like this and maybe potentially even use it in the future. So it's interesting how people are trying to use open technologies like Arduino and the digital fabrication to create open versions of machines that we are used to see every day. So the same person who did this project with the CAT scanner, now the image here I didn't put it, he's also working on this project called Tricorder, which is loosely based on the electronics of an Arduino. And if you remember Star Trek, they had this device, now that whenever something happened, the doctor would open the tricorder and figure out exactly what kind of illness, what kind of, from what kind of planet this alien creature was coming from. So there is actually a couple of projects to try to create a device like that. So something that's got a lot of sensors that you can open and can analyze very quickly something that you have in front of you. A device like this, for example, can tell you if water you're about to drink is drinkable, it's poisonous, or if there's some feature or some food is still, if there are some issues with the food you're about to eat. So there are a number of these tools that are happening. And this, again, it's an interesting evolution of the attempt to use these open platforms to solve real hard problems. So this was mentioned before in the processing of, when you try to analyze DNA, you need this machine called PCR, and a group of researchers made this open PCR. It's a machine where the hardware, the construction, everything, the software, it's all open source, downloadable, and you can build it yourself. So using this tool and a number of other tools that are becoming available, you can create a chemistry/genetics lab with things that you can either build yourself or you can recycle from old technology. This is, for example, a project from a student in Brazil who made a pH probe. So in chemistry, you use this quite a lot. And with the simple circuit plugged on an Arduino, he was able to obtain a quality of data which is very similar to a commercial platform. But instead of costing a few €100, this costs maybe €20. Same goes for this story here. So this is a galvanostat. It's a specific device that's used, for example, when you research about materials and batteries in particular. So the guy who built this basically realized that in the lab in his university there were very expensive machines, professional, but it wasn't something that you could access constantly. So he wanted to build one, but the knowledge of how to build one was sort of lost because everybody bought commercial versions. So he found an old professor. They knew how to do it. They built one that you could plug on top of Arduino. And then they realized that with $80 they could make a finished instrument. So they started to also make it available to other PhD students who couldn't afford thousands of dollars of equipment. So this is another interesting area of like trying to recreate expensive scientific instruments in a way that are open and they can be made by anybody. There's a couple of other stranger devices. This is called the open informant. And this one, in a way, detects the emails and other data that you have in your phone and finds keywords that the NSA would find interesting and broadcast them on this display that you're wearing. So obviously this is more like a political statement than an actual device, but it's interesting, this way of like, what is interesting is that somebody was able to, using some off-the-shelf, in a way, components to build a fairly complex device fairly quickly, because this one contains an Arduino processor, a Bluetooth 4 module to talk to the phone, an e-paper display, a battery, and a charger. So these are all modules that you can buy online. So one of the cool things about this open hardware movement is that you can find stores online where a lot of pieces of technology has been made into a module, so you don't really need to know how to build the perfect battery charger for a LiPo battery. You buy a module, you plug it in your circuit and you use it. And so this idea that you package up knowledge in modules and you sell it encourages people with no experience in technology to build more and more ambitious devices. So this is essentially like a consumer electronic device. So another area where it's interesting what's happening with open source and open hardware is people are rediscovering old machinery, trying to give it a new life using electronics. So this is a Nitty machine. The most famous one were made by this company called Brother, and they were, but also came with other brands, and they were using them in the 80s, either with floppy disks or by using this kind of paper sort of, it's kind of like a punch card. You buy a magazine, there would be a pattern in the magazine. So by putting this punch card in the loom, and you would move the knitting machine with your hand, it would produce that pattern in the wool. So a number of people have realized that you could replace the floppy disk with an Arduino. So you could control the knitting machine from software. So you could generate patterns from software and not by hand. So they made software like this one, where you can actually generate a pattern through the software and send it to the machine. So for example, in this case, you can see they used it to produce essentially a black and white portrait of a person using wool. They also have a very nice video where they show that they are going into H&M. They're actually taking measurement of the dummies inside H&M, then they go back to the lab, and they're actually generating, using a software that's generating sweaters, hats, and other type of garments. They make them with a machine, and they went back into H&M, and they put these garments on the dummies in H&M. So in a way, they got to the point that they have a software where they say, I need a dress, a female dress with these measurements. You press a button, and the product comes out of a machine which has been bought on eBay for 200 euros. So the area, what's happening right now is that all this kind of experimental stuff is finally going through the stages of becoming real products. Like, for example, this product here is called a Smart Citizen. It's a sort of specialized Arduino compatible board with Wi-Fi on board that has a lot of sensors that measure air quality. So this little device is essentially an air quality monitor that you can power with a battery or with solar light, solar energy.